Pressing record. Here we go.
Okay. Good afternoon, everybody. SUT are pleased to have Hieu Le from Atkins today with us. Hieu is a senior naval architect with 7 years experience in both the oil and gas and offshore wind industries. I will now hand over the virtual mic over to you, Hieu. Please let us know more about yourself and the industry. Thank you.
Yeah, thank you, Shruti, and thank you, the SUT Plus, for inviting me to speak today. So it's my pleasure to speak to you about the offshore wind industry. So I'm going to the next slide to introduce a little bit about me. So I am a senior naval architect. I graduated 7 years ago from University of Southampton. I am an advocate for the use of LNG and offshore wind in the energy mix because it helps with the decarbonization. I was speaker at the Gas Tech 2018, and then the floating offshore wind 2020. And as you could see in my in the table here, I got a balanced experience between offshore wind and oil and gas. When I worked for London Offshore Consultants, for my first 6 years, I worked in offshore wind mobilization support, cable layer analysis, work with the company like Brisbane or the installation company like Jandanol or A2C. And for oil and gas, I work in FPSO, FSRU, mooring analysis, transportation analysis, and marine warranty services. When I joined Atkins 1.5 years ago, I started working on floating wind design optimization. I support the St. Brieuc offshore fixed bottom offshore wind project. And last but not least, because I grew up in Vietnam, I was helping with a very significant project called Offshore Wind Roadmap for Vietnam. It's a part of the World Bank initiative to help the Vietnamese government to develop the whole roadmap to develop a successful offshore wind industry in Vietnam. And through that project, I've learned a lot more details and aspects of an offshore wind, not just a technical aspect as usually an engineer would know. And also in oil and gas, I work in subsea storage tank, SPM, single point mooring analysis, and hull point analysis. But as you see in here, I'll be by no means an expert offshore wind. The information that I'm going to provide today is mostly on public domain and is interpreted from my personal experience. So I'm happy to discuss with you the information that I provided in the Q&A sessions. I did have a look at the LinkedIn, the list of attendees, and I was quite surprised by the amount of people who are quite senior in this call. So I'll discuss in the next slide of the scope of what I'm talking today. But before that, just a bit about Atkins and NNC Lavalin, just in case you didn't know. So Atkins is, I think, one of the biggest engineering consultancy in UK, and we are leading in engineering and construction, offering services in oil and gas, mining, metallurgy, infrastructure, and clean power. We were bought by SNC Lavalin, which is another one of the biggest consultancy, engineering consultancy in construction in Canada back in 2017. And together we got about 50,000 employees all around the world. And so what I'm going to talk today, so when I was asked to speak about this event, I was thinking of dig deep into quite technical details of each type of structure. But then I realized that this is for SUT Plus, so more or less of people with possibly less than 2 years experience in offshore wind. So that's why I decided to go into a wider subject and less technical. So if someone who has more than 5 or 7 years in offshore wind, they may find some of the slides quite straightforward. So if you want to discuss further on the technical details, then I would welcome you to contact me, and I will put you into some of the Atkins special technical talks, which we go really deep into each of the subject. For the talk today, I would cover what is offshore wind and why would we go for offshore wind. Then I go to the overview of the offshore wind market. Then we talk about the stakeholders because it's quite different from the oil and gas industry. And then I quickly go through the Atkins project examples just to give you an idea of what is monopiles, jackets and floating wind. And finally, there will be a question and an answer. Okay, so what is offshore wind? Why do people talk about that? So this is a very good picture about an offshore wind farm, and offshore wind or offshore wind power or offshore wind energy, they all refers to the use of wind farms constructed in the ocean, and it's to harvest energy to generate electricity. And the offshore in the offshore wind word refers to the ocean, and it is to differ it from onshore wind, which is a wind farm constructed on land. And when people talk about offshore wind, what people think of is normally the turbines rotating on a foundation, but the offshore wind is not only the turbines. The offshore wind is a system that consists of the turbines, the foundations, the inter-array cables that connect them, and then connect the turbines toward a offshore substations, and then the export cables that connect the substations toward the onshore facility, which then connect to the grid. And then in order to construct these offshore wind farms, there needs to be a lot of offshore installation vessels as well, which I'm going to talk about later on. So why do we talk about offshore wind, or firstly wind energy or renewable energy? So it's all started back in 1992, where the United Nations Framework Convention on Climate Change has concluded that two assumptions, which now is being confirmed, reconfirmed, that global warming is happening. Still a lot of people debating that, but we believe that global warming is happening. And the second assumption is extremely likely that the human-made CO2 emissions that have predominantly caused the problems. So as a result of this United Nations Framework Convention, we then have the Kyoto Protocol in 1999, and then Doha 2012, and then Paris COP21 in 2015. It's all working to reduce the greenhouse gas emission. So in 2007, the UK government agreed to the European targets of 20% energy supply from renewable sources by 2020, which is equivalent to 35 to 40% of electricity from renewable source. So energy supply includes the electricity and then other home use, heating and transportation. So the electricity itself is only 35 to 40. There's a difference between the percentage of energy supply and the percentage of electricity. And then in 2008, we got a Climate Change Act, consists of a commitment to reducing greenhouse gas emission by 80% in 2050. And people often talking about the energy dilemma, because we want to reduce carbon emission, we want to have a lot of energy security, and then we want to have low energy costs. And normally one will contradict each other. And offshore wind is one of the way where we could reduce all three of them: reduce carbon emissions, we reduce energy costs, and at the same time we increase the security of energy that's generated within UK. So I did a bit of research. So back in 2011, we got some ambitions of the Scottish government, Northern Ireland government, Welsh government, and UK government in here. And we've done really well. The next slide, I'm going to talk about how we're doing now. But you see that the government has really committed. Boris Johnson, I think, at the first time talked about a lot about wind farm that could power every home by 2030. And you see, I think very recently, just last week, European Union aims for 300 gigawatt of offshore wind by 2050. And if you look in the next few slides, you'll see how much it's more than what we say we're having now. So where are we now with the energy mix? So I've got this information from the Department of Business, Energy and Industrial Strategy report in September 2020, and you will see this compare the energy mix in the second quarter of last year and this year, and you see the significant increase of the renewables contribution from 35.6% to 44.6%. So renewable energies now is a leading source of the energy mix. And out of that, you see on the right-hand side, the contribution of the different source. And so the majority of the change in here is because of the offshore wind. I think the report says that 80% of the increase in the renewables was caused by offshore wind. And you see in here that the total renewable generated roughly 43 kilowatt hours. If we look back this number from a different report, that we managed to reduce 13 million tons of CO2, and then we got 30% of this is back in 2019, UK offshore wind generated because of the offshore wind. Another question I often have is, why do we go offshore for wind? UK is very windy, and if you're in Aberdeen or in Scotland, that must be you must question yourself, why can't we go for onshore? And another one, when I work in Australia, it's a country with a lot of lands, and they say we have enough lands for onshore wind, we don't need to go for offshore. So I found this figure from the EDF website, which is very useful. So yes, we can do onshore, and we still do onshore wind, but the offshore wind has certain advantages. The first of that is the wind speeds in the oceans are much higher, and it's more consistent. And the power that it generates is proportional to the wind speed, the cube of wind speed. So you can see that there's a lot more energy generated by offshore wind than onshore. And then also, because for onshore facility, they will have difficulties of transport a very big wind turbines or tower onshore to the locations due to the weight limit. But for offshore, you can just transport that on a barge and using a crane installation. So you see that the wind turbine for offshore, I think they have some feasibility study for 15 megawatt. They surely use a 12 megawatt, and the install and up running possibly 9 to 10 megawatt right now. So that is much bigger than the biggest onshore one, which is 4.8 megawatt. And also another thing about offshore is that the community impact for offshore wind is much less. Onshore wind tends to cause a bit of troubles for every place lands of people who use, and then it causes some disturb in the area. So offshore wind could avoid a lot more problems than that. And because of I mentioned in here, the cost of energy for offshore wind is quickly decreasing, which I'm going to show in the few slides. So this one is what we summarize for the strategy of the government and the reduction rate that we thought. So back in 2012, where we were at round one CFD. So CFD round is stand for contract for difference. It's a terminology that takes some time to understand. But it basically each CFD round is each time the developers have the chance to bid for a strike price at which UK government will commit to pay. And that strike price is the contract for difference, in a way that if the market price is higher than that strike price, the operation company will pay the government, and if it's lower, the government will pay. So it's almost like a confirmed price, and it's a reduced risk for the developers or the operator to commit on offshore wind. So back in 2012, the strike price for offshore wind is I think it's about 120 pounds per megawatt, and it's thought it would be about 114 in 2019. and then even in 2016, they thought that would be 96 by 2030. But the fact is that I think for the latest one, we got cheaper than nuclear. We got some later on that's very, I think 74.75 pounds for Tritonal, and then 55.5 for Hornsea 2 or Moray. So this dotted line is a predicted cost reduction, and the actual cost reduction was a lot lower. And then you can see that the world's first subsidy-free auction was done in Germany. So we've done really well in reducing the cost for offshore wind, and it will be say that it will be cheaper than other sources. So now we go for the offshore wind market. Some overview and the updates of where we are in the world and how we do that. So some of you possibly already know the UK is leading for offshore wind. We look in here is the capacity of offshore wind in the next 10 years within Europe and around the world. And you'll see that the column here is the amount of annual install capacity in megawatt, and the right hand side here is the cumulative install. So you will see that up until now we got about 25 gigawatt in Europe, and UK has contributed a significant part of that. I'll show you in the next slides. And globally, other than UK and Europe, we got ones developed in China and Taiwan, and then the other countries, including Vietnam, in the future. So you might see that it seems from this graph that there's some sort of drop in annual install in 2050 and 25 in the next few years, but I don't think it is the case. It's more or less on some of the CFD round that only limit up to this year, but there will be more confirmed. So I would expect these columns will go up and up in the years to come. So where offshore wind farms are installed. So as I promised in the previous slide, UK has contributed 45% of the total install offshore wind, and then next one is Germany, Denmark, Belgium, and the Netherlands. So the first 5 countries contributed 99% of the all European capacity. And from this right-hand side here, you will be able to see where the offshore wind are installed. So the green colors are the operational wind farms, and there's the few big ones are the Hornsea 1.2 Hornsea 1.2 gigawatt, Walney extension 659, London Array 630, and Beatrice in here of 588 megawatt. The yellow one, for example, these one are under constructions. So we got Hornsea 2 of 1.4, Moray of 950 megawatt, and East Anglia was 714. And then the red one here, the Dogger Bank wind farm that has secure contracts of difference from the government, but not yet started construction. And actually this morning, there's a very good news that Dogger Bank, I can't remember which Dogger Bank, but they got a final FID, which is a final investment decision. I think it's the same concept for oil and gas. It means that they committed to develop that one. And that Dogger Bank was owned by SSE and Equinor. So I like to talk a little bit about a leasing process, and I've just used Scotwind as an example. So just back in terms of just a bit back into the background of who owned the seabeds in UK. So in England and Wales and Northern Ireland, the Crown Estate is the owner of the UK seabeds up to 12 nautical miles from shore. And then there's the Energy Act 2014 that gives the Crown Estate the right to license construction of renewable energy assets within the renewable energy zone of out to 200 nautical miles. And then in the Scotland, the Crown is the Scotland's Crown Estate or Marine Scotland own the seabed for Scotland, so they have the leasing process separately. So for within England, England, Wales, and Northern Ireland, we already got 4 CFD rounds. But for Scotland, this would be the first leasing ground for the decade. And generally, the process would be that the developer would identify the potential site, and then they apply for option agreement. The Crown Estate will then evaluate the application, award the agreement, then and then give the agreement for the developer, which then they go for the consents and secure the consent from the local community. And this is where they would propose a strike price, and then the Crown Estate would decide whether they would give it to the developer. It's quite a complicated process. I just give you this. There's an idea about the leasing process, and when you work on each of them, you identify where you are. And I particularly spend more time in here because I talked to the SUT Aberdeen, and I thought you would be quite interested in the development within Scotland. So I hope you remember the previous process, and it's going on very quickly, and the option agreement will be given to different developers in August next year. That would basically mean there will be a lot of engineering work that will start at that time, and there's a big opportunity for everyone to join in. And I think it's good to start your action now to learn a bit more about offshore wind. And I'm very happy that a lot of people attended today. So who are the offshore wind stakeholders? By stakeholders, I do not mean the local communities or other. I mean who involved in the construction and operation of offshore wind farms, because it's quite different from the oil and gas. So in the world of oil and gas, you're possibly familiar with Sinopec from China, Royal Dutch Shell, Saudi Aramco, BP, ExxonMobil, Total, Chevron, Repsol, for example. In the offshore wind world, the names are slightly different. So we got Ørsted, which previously named as Dong Energy from Denmark, RWE from Germany, Vattenfall from Sweden, Macquarie Capital, sometimes it's called UK Green Investment. I think they originally from Australia, but they are a global company. And then we got Global Infrastructure Partners, SSE, you recognize the operator, Iberdrola, and Equinor in there. So this is a typical offshore wind multi-contract structure. So in the oil and gas world, you're possibly familiar with EPC contractors, so like of KBR or I can't think of another name. They normally or Technip, they will take the money from the owner and then deliver the whole project. So the first few projects in offshore wind, they did go for that, but later on they realized that they will gain a lot more efficiency by giving a multiple contracts to different packages. Some like Ørsted very proud on their efficiency of handling, so they have multiple contracts, while other like Iberdrola would deal with some top contracts, which then will subcontract to other. And I think that's the conclusion from ORE Catapult. It's not my conclusion. I just want to share with you on that. And you see in here that they are color coded. So normally the one for the same color would be provided by almost the same provider. So the cables are such as the substation structures, electrical supply, foundation. I think I may have mixed. No, the cable supplies are normally provided by Prysmian, JDR, Nexans, LS cables, and then the installation services would be done by the like of DEME, Deep Ocean, Jandanu or Van Oort, and you might see some familiar name from the oil and gas like Subsea 7 or Boskalis or Van Oord as well. So there's quite a lot of transferable skills and knowledge transfer from the oil and gas and offshore wind within the installation area. And then the turbine supplies is dominated by Siemens Gamesa and Vestas. I think Gamesa was sort of 60% and Vestas was 30%, and the rest of them is shared by other within the offshore wind. I'm not talking about onshore. Onshore that might have other, and that's more on Europe side. I don't have the number for Asia. And then foundations and substation supplies are normally shipyards, and then they manufacture the substation and foundation based on the design and provided by the companies like design house like Atkins. So where again I would say where Atkins fits into and what Atkins roles involvement in the offshore wind industry. So we got about 45 years experience in the offshore wind, and that's why we've done a lot of integrity management of offshore structure, and up to now we design 20 offshore substation, more than 370 wind turbine generator foundations, and then 5 floating wind farm, which I'm going to talk later on in the presentation. Just looking at the time, 30 minutes. Okay, so now we go for project examples. So here's where the Atkins projects are. So use the deep blue is where we did the concept design studies. The dark one is for concept and detail design. The red one is only detail design, and then there's baby blue is asset management. But mainly it showed that we got involved in projects across UK and some in France and other part of Europe as well. And this one was posted by Atkins because I think coincidentally this one is a wind. I think the week for wind energy. So it's really good that we have this webinar today. Okay, so these are the flagship offshore wind projects of Atkins. So we did the Beatrice in Scotland. We designed 84 wind turbine jacket foundations, and then we got the 65 monopiles of Dungeon, 90 monopiles from Tritonal. We work as an owner engineer for Blythe demonstrator for EDF, and we help with the Kincardine and Windfloat demonstrator. And we particularly strong on offshore substations. We did feed and detail design of 8 substations for Ørsted, Hornsea, Racebank, Warney, and Bubble Bank, which I'm going to talk in the next few slides. So I will have one slide for monopile, one slide for jacket, and one slide for floating, and then I'll leave a lot. I think I intentionally leave quite a lot of time for Q&A because I think it's very generic presentation. There will be quite a lot of questions from you, which I could go to more details. And just worth noting that most of this project was done before I joined Atkins, so I could only speak to a certain level, but I don't know the very details of these projects. So start with monopile. Monopile is the most common foundation design in relatively shallow water. I would think it's about 60 or 70% of the offshore wind now is from the monopiles. So for people who are not familiar, it's called monopile because it all has one pile that connected to the soil in here, and the top of that you have the offshore wind turbine. This is and there will be a transition. I think there will be a transition piece to connect the turbine to the monopile here, and this is where the boat landing and the people will climb on the boat into this platform and then get into the turbine. So we have, as I mentioned before, we have designed the turbines for Dungeon offshore wind and the Tritonal, which has the largest offshore turbine at that time of 9.5 megawatt. And offshore wind is the monopile is go into the deeper and deeper water, and there's a lot more application on that. jackets substructure. So when it gets to deeper water, monopiles getting less advantages and jackets will be more prevalent, and they designing jackets borrow quite a lot of experience from the oil and gas industry. So the general about jackets, you would have a pile that dig into the soil to keep it in place. There will be a step in that get the jacket to the pile, and you got boat landing area in here. You get the transition piece that would connect the jacket to the tower of the wind turbine, and you have this platform where you got different equipments in there. And energy level in Atkins, we have completed design of 84 jackets for Beatrice, and I think it's 63 jackets for Sangrid project. We're doing that at the moment. And as you see in here, they are the jackets that assemble in the quayside before transportation, and in the shipyard. So the bottom part of the top part of the jacket is normally painted for corrosion purpose. The one under the water would not need the same amount of protection. Last but not least, floating wind. This is where my interest is because I'm a naval architect. So floating structure has potential to be used in very deep water, and it could avoid heavily vessels offshore because it normally installed in the quayside and then towed to offshore location and install the mooring system. And there's a various type of semi-sub, various type of structure, including semi-sub, TLB, and spar. So Atkins has involved in the design of many floating wind before and at the moment. And for offshore substation design, I'll talk about that at the early stage of at the first line. If you remember, all the offshore wind would be connected by inter-array, which lead to the offshore substation, and then from there they will, I think, increase the voltage and then use export cables to transport transfer the electricity from the offshore substation to the onshore substation. It's quite crucial for any wind farm, and we've done the primary and secondary steel design for a number of offshore substations so far, and yeah. And we also done the structural integrity management. We're very strong in there for the North Sea, and then we also moved that toward the offshore wind for Greater Gabbard. And we've done the response monitoring, condition monitoring, corrosion inspection, reliability, and remediation design. If it happens you see some corrosion and scratch that might affect the life of offshore wind. So I put a list in here, which I'll definitely share with you the slides in here, which is very good reading. So this is the very simple reading about wind power from the EDF website. And then there's this one for the Crown Estate. It's absolutely amazing for everyone wants to know about terminology in different parts of offshore wind, very detailed pictures and explanation. Atkins also, we have an offshore wind handbooks written for USA, but very useful. And then there's, in terms of all the statistics that you've seen in this presentation, you'll be able to find in these 3 reports. And then apparently all the offshore wind news will be updated. You'll be able to update by subscribing to some of the website. So I think that's the end of my presentation. And if you have any questions, my name is Hugh, pronounced as Hugh Grant, in case you wonder how to pronounce my name.